Electrons, which are found around the nucleus of an atom, they have a unique way of existing around the nucleus. It is actually something that science currently is just beginning to understand. But at the beginning of the last century, in the 1900s, few scientists actually were able to understand the behavior of electrons and where exactly they reside. And what they gave us is a bunch of numbers known as quantum numbers. Now, the quantum numbers, for all practical purposes, are going to be very easy to understand. N is the first quantum number, and instead of calling it N, we will simply call it shell. Electrons are found within different shells. The value of N must always be an integer greater than 0. All right, so the value of N can be something like N equals 1, N equals 2, 3, and so on. Within the shell N, we have something called the subshell L. Because it is within a shell, it depends on the shell. And the value of the subshell L the smallest value must be 0, not smaller than 0, but it must be smaller than N while still being an integer. So if N equals to 1, your subshell L can only be a value of 0. If N equals 2, your subshell within that shell starting with 0 will be 0 and a 1. Then when N equals 3, your subshell L will be starting with 0, 0, 1 and 2. Likewise, to avoid confusion, we are going to actually create an alphabetical designation for the values of L and keep integer values for the value of N. So L of 0, we will simply call it by the alphabet lowercase s. L value of 1, we will call it by the alphabet P. A value of 2 for L is D. And finally, a value of 3 is F. S, P, D, F. Those are the 4 subshells. Now, where exactly do the electrons reside within the subshells? Well, that's where something called orbitals comes along. Orbital, many times designated as ML, is where the electrons actually live. Now there are different number of orbitals within a subshell. So for S there is only one orbital. For P there are 3 orbitals. For D there are 5 orbitals, and for F there are 7 orbitals. And within each orbital, this being our orbital, we can have a max of 2 electrons. So when we have one orbital, we can have a max of 2 electrons. But when we have 3 orbitals, each one having a max of 2 electrons, means that 3 of them should allow 6 electrons. Similarly, 5 orbitals allows 10 electrons, and 7 orbitals allows 14 electrons. All right, so now let's recap what we learned. There is shell, starts with N equals 1 and up, integers only. Within the shell we have subshell L, starts with L equals 0 but must be less than N. also only integers, and ml are orbitals. Within s subshell there is only one orbital, max electrons allowed is 2. Within p subshell there are 3 orbitals, max electrons allowed is 6. Within d subshell there are 5 orbitals, max electrons allowed is 10. And within f subshell there are 7 orbitals, max electrons allowed is 14. With this information, we can actually write down the electron configuration of atoms. And when we write down the electron configurations, we are basically assigning an address to every electron in an atom. For example, carbon atom has 6 electrons. Where exactly do those electrons reside? In which shell do they reside? Maybe some of them reside in n equals 0 shell, n equals 1 shell, some reside in n equals 2 shell. And also within the shells that the electrons reside, what subshells do they reside in? And how many of the orbitals are fully occupied with 2 electrons? How many of them only have 1 electron? That is what electron configuration allows us to write. Before we write electron configurations, one last thing to mention is we are going to put electrons in their shells, subshells and orbitals starting with the smallest value of the shell, n equals 1. And also within the n equals 1 shell, we will put the electrons in the smallest subshell, L equals 0, which is S. Then when we go into n equals to 2, we will start with again the smallest subshell, L equals 0, and then we go into L equals 1. And then when we go into n equals 3, we go into again L equals 0, then 1, and then 2. The smaller the values, the lower the energy of those shells, subshells and orbitals. And atoms like to possess as low energy as possible. It keeps them stable. High energy means instability, lack of stability, which is not what any atom wants. They want to minimize the amount of energy they hold. So they will put themselves starting with the smallest shell and the subshell and the orbitals. We will look at that next.